Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at the Ethernet MAC address. We'll be discussing MAC address and hexadecimal, Ethernet MAC address, frame processing, and then finally we're going to look at unicast, broadcast, and multicast MAC addresses. This episode is part of my series on the Introduction to Networks for the Cisco Certified Network Associate, also known as the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. The Ethernet MAC address is 48 bits long in binary. That means it's a string of 48 ones or zeros. And then what we do is we take and we express that in 12 hexadecimal numbers. We change it into hexadecimal numbers for us humans to better understand that. And what we can do is we take the binary 8 zeros all the way up to the binary 8 ones, and that is equivalent to a hexadecimal 00 to hexadecimal FF. So 8 zeros in binary is equal to hexadecimal 00. 8 ones in binary is equal to FF. When using hexadecimals, the leading zeros are always placed in there. We need to make sure we represent those 8 bits. And so if we have a binary that starts off with 4 zeros and then 1010, so we have 4 zeros, that's equivalent to 0. 1010 in binary, we convert that into decimal. That is the number 10, but in hexadecimal, there is no number 10. So what we have to do is go from 9 to 8. And so the binary of 4 zeros followed by 1010 is equal to the hex of 0A. And once again, we need to make sure we put that leading 0. Now, sometimes to identify that it's a hexadecimal number, we put a 0 and a small x before that. And so you would see something like 0 small x and then the number 0A from our previous example here. That would identify that 0x as what's coming after it is a hexadecimal number. Here we have an Ethernet MAC address. If we look at it, this is our string of 48 ones and zeros all the way across here. That is how the computer understands a MAC address. It sees it as ones and zeros, 48 bits long. What we do for humans is we break that 48 bits up into 4-bit pieces. We break that up into 4-bit pieces. We turn that into a hexadecimal number. Then once we have our hexadecimal number, we go and we take the next 4 bits. And when we get 2 hexadecimal numbers, we combine that together to give us our byte. And if we go back and look at the binary, we remember that 8 bits make a byte. That's what we have right here. Then, when we finally display this MAC address for humans, what we have here is 6 bytes of information. 6 bytes of information. Typically, it's displayed as 12 hexadecimal numbers. And a lot of times between the pairs of numbers, we'll see colons, breaking it up. We could see dashes. Windows likes to use dashes between that. Or Cisco does it a little bit differently. How Cisco displays MAC addresses is it will take 4 hexadecimal numbers, put a period, 4 hexadecimal numbers, a period, and then the last 4 hexadecimals. Notice each version of displaying those MAC addresses to the humans all had a total of 12 hexadecimal numbers. 12 hexadecimal numbers equals the 6 bytes. That equals the 48 bits. Unicast MAC address. That, once again, remember, unicast is a one-to-one communication. One end device to one end device. What we have here is when we do a unicast MAC address, it's to a unique address. And if we look at the picture here, we have our IP packet here in the center. Our IP packet has the source IP address and the destination IP address. That, once again, IP addresses are a layer 3 address, and it connects our end-to-end connectivity. We encapsulate that with our frame address, and the first one here is the destination. So where am I going? On my local network, what is this next hop? And this happens to be the MAC address here of the server. You can see that right there. Our source is where it's coming from. It's coming from a PC that wants to send the message. That is the source MAC address there. Notice this is a one-to-one sending of a message. We have the MAC addresses here, our destination and source. Destination MAC address is first. When that source host sends it to the switch looks and says, do I know how to get there? If it looks in its MAC address table on the switch, it then forwards it out the port that's connected to the server. If that frame comes in, it looks in its MAC address table, doesn't match anything in our destination MAC address if it's not found in the MAC address table. What it does is it goes through an address resolution protocol, the process that a source host uses to determine the destination MAC address associated with an IP version 4 address. A broadcast MAC address is a little bit different. If we look down here at our destination MAC address, our destination MAC address is all Fs. If we convert that to binary, all Fs is all ones. Our destination MAC address is all Fs. Our source is where it's coming from. That source is the MAC address of our PC. When we send it to the switch looks at the destination. The destination MAC address is a special one. It's all ones. At that point in time, the switch will take that frame with a destination MAC address of all Fs and forward it out all the ports on that device except for the port it received it on. A multicast address is a little bit different than a broadcast address. A multicast address goes to a specific group of devices. Broadcast address goes to all the devices, but a multicast goes to a specific group. Now, how this all works is, first let's look at our packet here, our IP packet. 224 in the first octet signifies that this is a multicast address. This multicast address is the destination IP address here from our IP packet. And so when the frame is built, we start looking at how are we going to put these addresses in. Well, because this is a 224 IP address, multicast address here in our IP packet, over here we put a special MAC address in. The special multicast address for the destination MAC address, it starts with 01005E. That is the multicast MAC address. It's special, and that's for IP version 4. If you're using IP version 6, that address is 3333 when we encapsulate that. There are other reserved multicast destination MAC addresses that aren't necessarily used for IP. Spanning Tree Protocol, they have their own reserved multicast address. When the switch receives this multicast MAC address in here, what it does is it forwards out all the ports here, even if the device is not part of the multicast address. It forwards it out, the device receives it, strips off the multicast MAC address, strips off the source MAC address, strips off the trailer, and then looks and processes the IP address. When it processes the IP address, that is when the multicast happens, whether or not they listen to that IP packet. It was my pleasure to provide you with this wonderful episode on Ethernet MAC addresses. If you like this episode and you got value out of it, and of course, depending upon what platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on Introduction to Networks. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode of my series on Introduction to Networks. Once again, I'm Kevin. This here is KevTechify. I'll see you next time for another great adventure.